So hey guys, welcome to the demo video of our project PolliSync. So I'll be logging into my web application using Google obviously. So I've already logged in, but for new users, we have a three-step onboarding process. What is this three-step onboarding process, you ask? The user first enters their farm name along with its location using an interactive map. Then he selects a crop from the 5 supported crops, and finally he enters farm details such as its area, soil type, and the planting date. Once that's done, we arrive at a dashboard as you can see here. So it's too bright. Let me turn on the dark mode because I personally prefer that. So at the very top, you'll see a pollination suitability index or a PSI score, which is generated using our very own machine learning model. We've trained this model using trusted open source datasets and real-time weather data from NASA Power. It generates a score out of 100 along with low, medium, and high risk labels. The higher the PSI score, the lower will be the risk of pollination failure. Using real-time API calls, we fetch environmental data from Open-Meteo for weather, NASA Power for 7-day environmental features, and GBIF for actual pollinator sightings. Our backend processes all this data, feeds it into the machine learning model, and generates a PSI score out of 100, as you can see here on the dashboard. Below all this, you can see the current microclimate cards showing temperature, humidity, rainfall, and wind data in real time. But this data on its own does not provide much information to the farmer. So that's where our AI agronomist recommendation system kicks in. It is our personalized AI assistant powered by Gemini, which suggests the best practices for crops based on our farm's current environmental conditions. So instead of just showing numbers on the screen, it explains the reason behind those numbers, helping the farmer understand the data in a better way and act upon those data. Below all this, you'll see forecast graphs for temperature, PSI score, and the NDVI values, giving the farmer a complete overview of their crops' environmental features. So coming on to the new prediction section, here users can generate new pollination prediction for any of the registered farms. So I'll be selecting the Shangri-La organic farm. Clicking on continue, we get the summary of that farm along with its location and the area. After we click predict pollination, the backend fetches the data, feeds it into the machine learning model, and generates a PSI score out of 100. Now you may ask, why is this project important? So we all know that pollination is one of the most important processes for any plant or crop, but farmers often have limited data to tell them when the conditions are actually suitable for successful pollination. So to improve that gap, we've devised our project. So after that's done, our dashboard is updated automatically. So for Shangri-La Organic Farm, the PSI score is 26 out of 100, which is highly risky. So coming on to the history section, it stores all the results of the previous pollination so that the user can track how the pollination conditions have changed over time. Coming on to the analytics section, the analytics page provides visual insights and trends from the past predictions to support better farm decision making. Coming on to the My Farm section, here the user can view, edit, and manage all of the registered farms at one place. Coming on to the crop guide, it suggests the most suitable crop based on the location we've selected. So let us select Nashik, for example. So the most suitable crops are mustard, sunflower, and cotton. So coming on to our AI assistant, it uses a retrieval augmented generation or a RAG pipeline. We create contextual embeddings from every prediction and store them in Supabase. When a user asks a question, the most relevant context is retrieved and provided to the LLM. This allows the assistant to generate accurate, farm-specific recommendations based on the user's actual conditions rather than giving generic advice. So our crop's next flowering window is predicted to start on 2026-08-09. So that was all about our project, PolliSync. Thank you for watching.